To write the net ionic equation for the following reaction between cobalt chloride and potassium sulfide to produce cobalt sulfide and potassium chloride, first we should write the total ionic equation by splitting the aqueous compounds. But what do you mean by aqueous? Welcome to schoolaa, your online school. You may check your understanding by solving the individual questions. And good luck. Aqueous means dissolved in water, and ionic compounds, when they are dissolved in water, they will be dissociated into ions. Like here, cobalt chloride will dissociate into cobalt ions and chloride ions. So if we have 10 moles of cobalt chloride, they are going to dissociate into 10 moles of cobalt ions and 20 moles of chloride ions. Since in each formula unit of cobalt chloride, we have 1 ion of cobalt and 2 ions of chloride. So let's go back to our first chemical equation and split all the aqueous compounds. Cobalt chloride will be dissociated into cobalt ions and 2 chloride ions. Potassium sulfide is going to be dissociated into 2 potassium ions and 1 sulfide ion. Cobalt sulfide is not going to be dissociated since it's in solid state. Then potassium chloride is going to be dissociated into 2 potassium ions and 2 chloride ions. By the way, here this chemical equation is balanced. To learn how to balance chemical equations, I will keep a link for you in the description below. So when we split all the aqueous compounds and we write all the ions like this is called total ionic equation. Now, how to write the net ionic equation? We should find the common ions between the left side and the right side and then cancel them. Like here, we have 2 potassium ions on the left and 2 potassium ions on the right. We have to cancel them. And also we have 2 chloride ions on the left and 2 chloride ions on the right. So we should cancel them. And the net ionic equation is going to be cobalt plus sulfide ions gives cobalt sulfide. Here, the ions that we cancelled, which are potassium and chloride ions, we call them spectator ions, since they didn't interfere in the net ionic equation. So the ions that we cancel, they are called spectator ions. Let's have another example, the reaction between barium nitrate and potassium sulfate to produce barium sulfate and potassium nitrate. Here, to write the total ionic equation, as I told you, we should split all the aqueous compounds. Like here, barium nitrate will be dissociated into barium ion and 2 nitrate ions. Potassium sulfate will be dissociated into 2 potassium ions and 1 sulfate ion. Barium sulfate is not going to be dissociated since it is solid. As I told you, we only split aqueous compounds. And potassium nitrate is going to be dissociated into potassium ions and nitrate ions. And now, to write the net ionic equation, we simply cancel all the common ions between the reactants and the products. Here we have the common ions are nitrates and potassium. They are found on both sides, so we cancel them. So the net ionic equation is going to be barium ion plus sulfate ion produces barium sulfate. And the ions we cancelled, potassium and nitrate, are called spectator ions. Let's have another example, the reaction of solid potassium with liquid water to produce potassium hydroxide aqueous plus hydrogen gas. Here, to write the total ionic equation, as I told you earlier, that we should split only the aqueous compounds. And as you can see, only potassium hydroxide is aqueous, so the total ionic equation is going to be solid potassium plus liquid water gives potassium ion plus hydroxide ion plus hydrogen gas. And since here we don't have common ions between the reactants and the products, so the net ionic equation is going to be the same like the total ionic equation. Now, what if the question is to predict the products of the reaction between sodium chloride and silver nitrate. Here, this is a double displacement reaction. And for you to learn more about double displacement reaction, you can find the link in the description below that shows the different types of reactions. In double displacement reactions, ions are swapped. So here, sodium will join nitrate and silver will join chloride. And the products are going to be sodium nitrate and silver chloride. But how to predict the state for these products? Here is the question, and I want you all to listen carefully. To predict the state for ionic compounds, we should study this table, which shows the soluble and the insoluble ionic compounds. And by the way, this table is very important and you should memorize. It shows that all group 1 compounds are soluble, all ammonium compounds are soluble, all nitrates compounds are soluble, all halides are soluble except with silver and lead, all sulfates are soluble except with the following ions, all carbonates are insoluble except with group 1 and ammonium, all hydroxides are insoluble except group 1 and the following ions. So from the table we learned that sodium nitrate is soluble or aqueous, while silver chloride is insoluble or solid. And why it was important to know which compound is aqueous and which one is solid? Since when we want to write the total ionic equation, we should know which compound we should split and which compound we should not. So to write the total ionic equation, sodium chloride is going to be dissociated into sodium and chloride ions, silver nitrate is going to be dissociated into silver and nitrate, sodium nitrate is going to be dissociated into sodium and nitrate ions, while silver chloride is not going to dissociate since it is solid. Then we cancel the common ions between the reactants and the products, sodium and nitrate, and the net ionic equation is going to be chloride ions with silver ions to give silver chloride in solid state. Let's have another example, the reaction of silver nitrate with calcium chloride. This is also a double displacement reaction, and we need the table to predict if the products are aqueous or solid. So here silver ions are going to combine with chloride ions, while calcium ions are going to combine with nitrate ions, and the products are going to be silver chloride and calcium nitrate. If you still find it difficult to write the formulas of ionic compounds, I will keep a useful link for you in the description below. And now, according to this table, silver chloride is going to be solid or insoluble, since all halides with silver are insoluble, while calcium nitrate is going to be soluble or aqueous, since all nitrates are soluble. Then we balance the chemical equation by multiplying silver nitrate by 2, then silver chloride by 2. If you still find it difficult to balance chemical equations, also you may check the description for useful links. Then we write the total ionic equation by splitting all the aqueous compounds. So on the reactant side we have 2 silver ions, 2 nitrate ions, 1 calcium ion, 2 chloride ions. On the product side we have 2 moles of solid silver chloride, 1 calcium ion, and 2 nitrate ions. Then we cancel the common ions between the reactants and the products, nitrate and calcium. Then the net ionic equation is going to be 2 silver ions plus 2 chloride ions to give 2 moles of silver chloride in solid state. And now you are ready to solve the end of video questions. Please, if you are not, repeat the video again. Otherwise, solve the questions, put your answer in the comment section. If you have any question that I didn't cover in the video, please share it with me in the comment section. Share this video with your friends. Subscribe to my channel to stay tuned for more videos. See you in other videos and good luck.